Okay, another type of discontinuity is what we call the essential discontinuity. A function f of x is said to have an essential discontinuity at x is equal to c if the limit of the function is d and e. So for the case 1, if for a function limit of the function is d and e or does not exist because the limits from the left and the right side of x is equal to c both exist but are not equal. That is, the limit of the function has a limit which we call L here, and the limit of the function as x approaches c plus is having a limit which we call M. It means that they have an individual limit, but our L is not equal to M. Then the function is having a jump essential discontinuity at x is equal to c. For case number 2, if a function is such that the limit is d in a because either the limit of f of x as x approaches c negative is equal to positive infinity, or the limit of f of x as x approaches c negative is equal to negative infinity, or the limit of the function as x approaches c plus is equal to positive infinity, or the limit of the function as x approaches c plus is equal to negative infinity. Then a function is said to have an infinite discontinuity or infinite essential discontinuity at x is equal to c. Okay, another example. Determine the type of discontinuity of h of x at x is equal to 4. Our h of x is equal to x plus 1 if x is lesser than 4, and quantity of x minus 4 squared plus 3 if x is greater or equal to 4. Now, first is let's determine the limit of the function at x is equal to 4. Now let's start with the limit at the left side. So limit of x plus 1 as x approaches to the value of c, which is 4, negative, so 4 plus 1 is equal to 5. So the limit is equal to 5 for the left side. How about for the right side? Limit of h of x as x approaches 4 plus, so it means that we will use the second equation because the x is greater than 4. So quantity of x minus 4 squared plus 3. So 4 minus 4 squared plus 3, so that's 0 squared plus 3, so our limit is equal to 3. So this is the value of the limit at the right side. Since the limit on the left side is equal to 5, which is not equal to the limit on the right side, therefore the limit of the function as x approaches 4 is d in e or does not exist. It means that our function is discontinuous. Okay, how about the h of c? So the h of 4 is equal to, we will use the second equation because x is greater or equal to 4, we will use the second piece. So x minus 4 squared plus 3, so h of 4 is equal to 4 minus 4 squared plus 3 is equal to 3. So the h of c is equal to 3. Now for the third condition, the limit of the function is not equal to the h of c. So this continues at x is equal to 4. So the function h is discontinuous at x is equal to 4. The question is, what type of discontinuity is this? A. Irremovable. B. Jump essential. C. Infinite essential. Okay, so obviously the answer is not letter C, infinite essential, because we are not dealing infinity in this problem. If you answer letter A, removable, this is also wrong because according to the removable discontinuity, the limit must exist. In this case, the limit is DNE or does not exist. Therefore, the answer is jump essential. So, a jump essential discontinuity is the limit does not exist, but they have the limits on the left side has an existing value, and also the limit on the right side has an existing value, but they are not equal, so they are DNE. So this is a jump essential discontinuity. Next question, is there a way to make h continuous at x is equal to 4? Yes or no? What do you think? Okay, the answer is no. So unlike removable discontinuity, jump essential discontinuity cannot be fixed. You can verify that here on its graph. So this is the graph of the function that we have solved earlier. We can see that the at x is equal to 4, our limit of the function is DNE at that point. And yeah, it's a jump essential discontinuity, and there's no way for us to fix this one. It's totally different graph of a function.